Anyone else want to come up? When do you think you will be using pig? Guys, some guesses, something is where.
Neeraj, I'm just going to take a shot. I think what you said was when you are working more with like not unstructured data, but it's like the data sometimes. I mean, you want the system to intuitively understand the data. Like you don't know exactly how the data is going to look like. For example, I think you gave that thing about number of columns and you said, if I upload a file with 20 columns, but then the system is set up only for 5 columns, you cannot do it with Hive, but Pig will automatically understand that it's only those 5 columns and do the matching by itself. So those types of cases, is that correct?
Yes, yes, perfectly fine. Yes, and basically unstructured data you can very easily process with pig as compared to hive, because here you don't have to create the data, the structure. You don't have to do anything. You can just search in the lines. You can do anything, but that is little difficult in hive. Everything is possible in hive also, map reduce also, but the easiness is very much in pig for unstructured data as compared to structured data for hive. So when the data is highly structured, Hive is the best candidate. When the data is kind of semi-structured or unstructured, Pig might be a better option for you to choose. And also for the queries on the fly kind of thing, like Pradeep was saying, yes, Pig would be a better choice as compared to Hive, because on the fly you can just write a query without defining any data types, any column, just filter out anything, some of the things what you want to produce output, use that output in the Hive. So yes, I agree. Okay. So I think now your people are getting at least the concept, the different things which are there in this world. All of them help you to process the data, but the way they help you in processing the data, the places where they will help you would differ, might differ. You have to precisely choose them. But all of those will help you in data processing in batches. None of them is real-time, is real-time processing, but all of them would help you in batches, batch analysis. Okay, so we looked into the different data types available in the peg. Then we also looked into a problem statement where we were able to map the flow diagram directly with the code. So we directly map the flow diagram, what we will be doing to solve a problem with the code. And then we looked at the different operators available in this area. We did not look into detail about each operator, but we definitely looked at what are the different kind of operators there. Sorry. Then we looked at the complexity of MapReduce code, which we could have write to resolve this issue or basically solve this problem. And then we looked into another problem where we tried to find out top URL hits by age category, and we saw how easy just a 6-7 line course which could do all this thing, which would have been too complex in the MapReduce world, or even if you use any other language to process this data which is lying totally unstructured in 2 different files for you, and you just write 6 lines of code and you are able to find out analytics on top of data. So you can think of the kind of work you can do with just writing 4 or 5 lines over here, and the kind of analysis you could do on the enormous amount of data. And the beauty about this technology is, or indeed this world is, you don't have to think about scalability of the system. If you can recall, if you would have been writing, codes or something in your developer time, the first question which people have arised or manager would have arised is, what if the system grows? What if the number of users increases? What if the data flow in the system increases? But when we are dealing with these systems, the code will remain same, only these 6 lines of code. We don't have to worry about the scalability of the system, the complexity, all of those things are handled by a framework. All you have to write is just 6 lines of code. At the back end, your infra team might add few data nodes for you to process the data, but you don't have to worry about. Your code will remain same. The scalability, all those things are gone away. You don't have to worry about any of those things. Just put extra nodes if you think you require more processing power. Use elastic clusters. You know what Amazon does? Elastic clustering, elastic cluster. What does that exactly mean?
Sorry, what clusters?
Elastic.
It will go up or down based on the requirement. I mean, it will shrink or expand based on the requirement.
Yes. So when the Christmas time comes up, Amazon clusters automatically expand. And when the load is less on the website, the clusters or the nodes on the cluster automatically get vanished, basically deleted from the cluster. So that's a beauty. As the load comes up, you increase your cluster. As the load goes down, you decrease your cluster. So you don't
Now,
wait.
is that configuration or is that some like special? Is that configuration in Hadoop or is that coding?
I'm not talking about Hadoop over here. I'm talking about the clusters which are coming up over here. So it's Amazon Elastic cluster which I'm talking about, not related to Hortonworks or Cloudera. I'm talking about Amazon over here. So those are Elastic clusters. So they come up based on your as the load increases, they add the nodes. The data is automatically replicated in S3. So the same thing, the same concept happens in AWS also. Everything is almost same. The names are changed. If you look over there, if you look over there, I'll not waste much of time. But the same technology would be available over there. Instead of HDFS, there's S3. Instead of your Scoop, there's something else. The name changes. The MapReduce, there's a similar thing for MapReduce over there. The name changes, but the concept is almost same over there also. So, but the beauty about there is they also give you the elasticity in the cluster, so you can reduce the credit card bills based on the cluster loads. I found very pretty great example of big data. I think last week. One of the father of 19-year-old girl entered shouting into Target. Target is, I think, in one of the big leading chains in your groceries and all those things. Not only groceries, I think in the fashion and all those things. So he entered the store shouting on the manager, "How dare you can send the prenatal discount vouchers to my 19-year-old daughter? Do you think she's pregnant or she's going to be pregnant at this age?" And after a fight with the manager said, "We are sorry, sir. We apologize for the mistake. There's some issue. There might be some problem with our system. We'll ensure that such kind of vouchers do not reach you or your daughter." After 10 days, the father called the manager and apologized him. He told, "My daughter is in second trimester of the pregnancy, and Target knew prior than me this news. And why Target knew is by looking into her buying pattern. She was buying the vitamins and some particular things which people normally buy in their second trimester or first trimester. And based on that, Target found to know that she was pregnant and offered her the discounts which she would be using at the time of baby or prior the baby getting delivered." So this is a big data world. So interesting thing which I found out. So then we looked into the schema, and I'm not sure where we left. I think we looked into this schema example also, where the schema is basically decided based on the operation which you are doing on the data, right? Sorry, Pradeep, I did not got you. So the moral of the story is go to HR. So, so they did not found out from the doctors. They found out based on the product which she was buying from the target stores.
That's true, but it's possible that the doctor prescribed it. If you go to a witch doctor, they'll give it to you in your hand. You don't have to go to a store.
Yeah. So, did we cover this part, schema part, or we left over here? Can someone recall me, or do you want to look over it again if you can't recall? Okay, no answers. Okay, I'll assume that we covered this part. If not, you can just pick me up right away. Okay, then by default every data type. Okay, I would have covered this also then. Okay, so pick basically tries to typecast your variables. Warning would be thrown if the casting fails, the process still goes on. Null will replace the inconvertible data types in the typecasting if the data types are not able to convert or if by based on these operations which we are discussing over that time. In the last class, if the pig is not able to convert them, those are replaced with nulls, and user can look into the corrupted records by detecting the nulls in the output of your data process data, and that's how we can look into the corrupted records. So for example, let's see over here, I have the temperature data, which has the first column is the year, second column is the temperature, and third column as the quality. So what I'm looking at is I'm trying to do some analysis on this data, and I have loaded the first column as char array, second column is integer, and third column is integer. But if you look at the third record over here, which is E, that means this temperature was not properly recorded from the satellite, or there's some issue with this temperature, and when we process the data with the help of pig will load this data, but this is not loaded over here, if you can see, and then when we look into this is null. And this is how, so what I did is filter records where temperature is null, and this is how I can look into the corrupted records which are loaded by the pig or which we have processed by the pig. Pig will not throw any errors for you if it's not able to typecast the way you would assuming that variables would be, or if you have not defined the variable data types, Pig will try to typecast based on the operation which you are doing on the data, but it will not throw any errors if it's not able to typecast the variables. It will just throw you warnings. Okay. So there are few things which are case sensitive, there are few things which are case insensitive. Just look into this, otherwise while writing the program you would be a lot of time facing some issues, and you will keep on debugging, and later, and after wasting hours you will find out your pig was case sensitive. So pig is not exactly case sensitive, but there are few things in pig which are case sensitive. So the keywords are not case sensitive, that is the operators which I was talking about, all those things are not case sensitive. This load is equivalent to this load. Field names are case insensitive, so when I say A is equals to this, I can't use A is equals to this. So the statements which are initialized to some variables, those variables are case sensitive, and UDF, that is user defined functions, are also case sensitive. So if you are using count function, remember you can't use this as count, you have to use this as count. Everything is capital. So the UDFs and the variables which you define are case sensitive. However, the operators which are there of the pig are case insensitive. So while writing the pig statements or scripts, please be aware of all these things. This is how you can write a comment in the pig program. So either you can use SQL style comment like this, or the Java style multiple line comment. So this is how you can write a comment, or inline comment kind of thing. So this is how you can comment your data. in the pig, and this is also one of the examples. So these are the three examples how you can write comment in pig language. Let's look into the different pig functions which are there, which we have looked into the previous example, but let's look into them in a little bit in depth. So these are the different functions which you're looking at. Most of those functions you would have definitely heard in the previous example which we have discussed. The eval function, filter, comparison, load, store. Load and store, now I hope everyone understand also. Load is to load the data, store is to store the data, filter is to filter the data. We'll look into the other ones in some time. So as these functions which I'm talking, which I've shown in this slide, are all functions which are there in the pig, but we can also define our functions, what we call UDF, user defined functions, and there are a lot of functions inside a jar which comes with the pig, which is called piggy bank. There are a lot of user defined functions for you, but you can always create your own functions. We'll look how to create the functions, our functions, and how to use them in pig. So let's first look into the store. When the output we were producing, we were storing that. So store helps you to store your data into the directory. So here I'm storing my data into the directory thus. In this example, I'm storing my data into the directory process using pig storage. I hope everyone understand what is pig using pig storage. Now does everyone understand what is using pig storage? Yeah, everyone keep on at least saying yes or not. That makes me feel that you are there listening to me. Oh, there is someone, Arvind Kejriwal, also in our session today. So I'm not sure who is he, but there is someone, Arvind Kejriwal also, and trying to do analysis on the vote bank. Okay, Pradeep said, Vikram said no, Pradeep was okay. So Vikram and Emily said no. Okay, so using pig storage will tell pig what is a separator you have to use while storing this data. This is similar to when we are loading the data. There also, if you can recall, in our slides we used pig storage. So if you are not sure, just keep on pinging me, keep on asking me as many questions as you can, as many questions as you ask, as the more detail I can tell you. So I will try my best to tell you most of the things, but still the more you ask, the more I'll be able to tell you. So wherever you think you are not sure, ask 10 times. I'll try my best to explain you. So if you remember here, we use using pig storage. So this is used to define or tell the pig storage function that what is a separator which you want to use in your data. So where here I'm saying using pig storage comma, I am storing the data. It's similar to when I was using it in load function, only the difference is now I'm storing the data, and my data, when I'm storing it, rather than the default tab separated, all the columns are, rather than be default tab separated, they would be separated by comma. So dump is to dump your data on the screen. If you want to look into the data or doing some debugging or that writing the program, at that time you might be doing a lot of debugging, looking into each and every variable, all those kind of things. So you can just use dump, and that will dump your data on the screen. Then there are other operators also. Let's look into them. Load, store, filter, join. So let's look into a few of the examples over here itself before we go ahead. So what I'm saying is store A into 1 minute. I'll just minimize this guy. So using pig storage colon. So here you can see all my data is stored something like this. column separated by colon. So using pig storage, now I have everyone can understand. Let's look into different things. Now I said dump A would be visible something like this only, because you are dumping that on screen, so that will be visible as a tuple only. But this is the same data which we have looked into this file, which was dumped by colon separated. And now what I say is, for each A generate $0. I hope $0 we understand, that is the first column, $2 plus 1 and constant. So rather than 3 columns, I have converted into 3 columns, but I have skipped the column, the second column in my data. So here I can see Zo, Ali, AO, and all those things, and then $2 plus 1, that is the third column, I added 1, and the third column I have added as a constant, as a variable, and is constant. So this is how I would be playing with my data. I say dump A, dump B. So A is, I hope you can see on the left hand side what is A, what is B. And after that, what I'm doing is join A by $0, B by $1. So I'm using the tie coat head scarf of the A to join with the B, and 2341 of the A, and joining that with B, the 24032. And if you can see, when the join, we have done the join, we can see the A and B are joined with the corresponding keys. So if there are two 2s in B, there are 2 records in the output. However, there was no matching for 1 and 0 in A and B respectively, and you can see there is no output of 1 and 0 in the C. However, 3 was 1 in each of the records, so it's 1 record of 3 and respectively for 4. But there were 2 records of 2 in the B, and that's the reason in the output there are 2 records with the key 2. So this is all inner join concept which happens over here. However, we can define the outer joins also. I'll talk about that. So here what I'm doing is co-group. Okay, co-group, let's leave for a timing. Co-group will talk. Co-group. Then there are other operators also which helps you to diagnose your data. I have describe, explain, and illustrate. Let's look into them. Those are very useful, and you will be using them a lot while debugging your program. So let me switch back to the pig console and let's look into them. Although I think I have described you these things, but let's look at them again, and let's check them. Just a minute. I'm just I'll come to you. Just a minute. Okay, so everyone, I hope, can see the pig console. If you can't, just ping me on the window. So here I am just loading one of the data which you have seen, I think, in the last class, that was NYSE dividends data. I have just loaded that data, and let's try to do some. So I loaded that as by the name of daily. If you can see over here, I've loaded that by the name of daily, and let's look into this. So DSCRIB describe. If I say describe daily, that will describe the schema of the daily for me. And the second thing which we were discussing was illustrate. So that will illustrate your daily, that will look into the data and will print you the data also along with the variable. So it will also give you the sample data along with the variable and all the things inside your variable which you are looking at. So open is the float, high is the float, and all those things. And there was one more thing which were okay, explain. So here I will not see much thing, but that will make sense when you are looking into the big play. So here I am looking into the execution plan, how that will be. That is similar to how you look at the query execution plan. It's almost similar. You can look into the different plan. Here it's just a single variable, and when we are doing complex operation on this variable, that will make sense to look into the explain, and that will tell you how you will be. How the data pipeline would be created and those kind of things. Okay, so this is how you would be looking into the data and the variables which you have defined, and you would be doing the debugging kind of thing. So this is what have been loaded, the records, and when we say describe records, we can see the year is described you as byte array. And I hope everyone understands that. Can anyone tell me why year has been represented as byte array and temperature and quality as int when I say describe records?
Is it because you did not specify and so it took the safest option?
Yes.
So that we will be able to deal with the data irrespective of how the input is.
Yes, and that's the reason that has been described as byte array over here. So that is assumed to be byte array. It tries to play safe, and the byte array is a thing which can be casted into anything. So it try to play it safe and use that as a byte array. Now let's look into for each. So for each takes a set of expression and applies them to every record in the data pipeline. So when I say for each on a particular thing, so if you can see over here, I say prices equals to NYSE daily. I've loaded the NYSE daily as by the name of prices. Now what I say is for each prices generate close minus open. So for each record, each record of NYSE would be looped through, and for each NYSE daily close minus open would be generated, and that will be assigned to gain. So if I say over here in the screen, so not this screen. Gain equals to each daily generate what were the names I gave? Open. Okay, I also gave open minus. Now if I say, see, it will also give you the some data. So see, open was float and close was also float. So it subtracted them and gave me for one of the record, for this record, and if I say dump, it will dump for all the records. So it will basically at the backend for each of those each of the record in that data set, it will do that operation for you. Okay. So who is there by the name of Arvind Kejriwal anyhow today? Who has taken the name of Arvind Kejriwal? Okay, Pradeep. So that is what I was saying you. But there are a few other things which you can use for each. So if you define something like this dot open, so that will take you all the columns prior to open. So in this example, if you can see, I have loaded 1, 2, 3, 4, 5, 6, 7, 8, 9 variables. If I say for each generate dot open, so only the column which are prior to open will be assigned to beginning variable. So that means exchange symbol date and open will be assigned to your beginning variable, exchange symbol date and open. The producer exchange symbol date and open. Similarly, if I say open dot close, so all the columns between open and close will be assigned to this variable. So it will be open, high, low and close, open, high, low and close. And similarly for each prices generate volume dot, so all the columns after volume would be assigned to this end. So volume and adjusted close would be assigned to this end. So this is also one of the easier way for lazy people like me. Rather than writing all the columns, we can just use these kind of short form also that will assign all the columns prior to this and iron to this and between those kind of things. Makes sense. So if we go over there and say for each daily dot open so see only the variables prior to open till open, exchange stock date and open. So then we can filter the variables. We have to just use filter. So filter the variable divs by symbol matches CM star. Here we can give the regular expression. Regular expression are normal regular expression. You can look the different regular expressions supported by Java, and same are supported over here. So it's a universal concept, regular expression. So you can use a regular expression to filter your data, and if you say not, something like this not, so this will filter only the records which are not matching your expression. So if I say sorry daily and by as TOCQ stock equal to mismatch input matches. I think this is not given in the course. Is it given in the course? And okay, this will start. What is the problem? Filter daily by stock. What is the problem? Filter daily by stock. So actually that is a keyword and that was giving an error. So I use the variable name as a keyword. So if we can see, the mat has only those stock which are equivalent to C star. So there was one CVH and C star, and the C star came in the output. And if I use the regular expression, so this gave me with the output. Then we can group the data. This should be here I'll be showing you some complex data types. So just listen into this thing a little bit carefully. So basically group will basically use to group your data onto particular by a particular key or something. So here what I'm saying, group daily by stocks. So my data will be grouped by stocks, and what that will generate is, let's look into this group daily by stocks. Sorry, I have to share the screen. Oh. And what is the name I gave? Let's use the same here. Now if I say, so if you can see over here, there are two things which I created for you. One is called group. That is that will be the variable on which you have grouped. So group and the variable which or the data which was grouped will be coming as a bag inside that group. So group itself is a bag. If you can see, that is starting with semicolon and ending with semicolon. So this whole group is GRPD is a bag, but that contains two things. One is your grouping ID, that or the element on which you have grouped. So here you can see we have grouped it on a stock. So, and that was of type char array. So a group is of type char array, and each of that thing contains a bag of tuples, and bag of tuples is nothing but all your dailies which match this stock. So if I say, over here, it has only taken two things as so it tries to intelligently also find out the data on which it has to illustrate. So it has taken two things over here. One is your these two rows basically. So, and you can see it has grouped it on CII, and the group has the value of the stock and the corresponding bag. In that grouped bag contains tuples of each daily which are matching that stock. Making sense? This is pretty interesting and pretty useful when you are really dealing with your data. I want a yes or no from everyone because this is very useful when you are dealing with the data. If you understand the complex data types, pig is very easy for you.
Can you can you once again explain? So you are piping the output of the group to you're piping it to daily. Is that what you're doing?
What I'm saying daily is a variable which need to be grouped on stock. So my daily, so this is the data of the day, your daily, which contains your exchange, the stock, the date time when there was a trade on that stock, and what was the open price on that day and the close price on that day, and so on. So now what I'm doing is I am grouping my daily data set on stock. So I'm creating different bags of each stock.
Right.
So when I'm creating different bags of each stock, my each row in this grouped variable would be a bag, and the key of the bag would be your stock because I've grouped it on a stock, and the value on the bag would again be a bag of each daily which matches that grouping criteria. Make sense? Or shall I open an Excel sheet?
Yeah, I think you should probably open an Excel sheet because
Okay. What about others? Everyone is silent. If you are not able to get it, please keep on asking me. Jignesh, Pradeep, Vikram. Pawan says okay. Okay. So Jignesh also said okay. So Pawan or Jignesh, would you like to explain? By the time I'm opening the Excel sheet. No answer. No. Okay. Okay. So let's say I have my variable daily. Oops. I'll just copy. So I think I got some good answer from someone. Pawan says you are grouping an ordered set into a tuple. I am grouping an ordered set into a tuple. Ordered set. I am grouping tuples into bags. So there's called UPLE. There's something called bag, and so when your data is loaded, it's loaded as tuple. So if I say over here, 1 minute, let me go back over here, and I say uh, limited is equals to limit daily 10. So let's get the 10 variables from daily, and I am saying dump limited. So I'm just trying to get 10 lines from my daily data set, and we'll use that in our Excel sheet. So it's just limiting your records by 10, and it will produce only the top 10 or some between based on the data it will be reading. It will produce 10 rows from your data. That is a daily variable, and then we'll use that to look into the results. It's taking a little time. I think there are a lot of things which I have started on this VM. Today I was playing with some other things also. Okay, by the time it comes, let me draw. Then it will come. So my daily was something like this. Exchange, stock, open, some others, and some others. Okay, so Infi trades on NYSE, but Sale does not trade on NYSE. ICICI trades on NYSE. And so on. So when I say dump daily, it would be dump something like this. By the time output would have been there, but it's taking a little more time. So let it dump, but it will be dumped as your tuple. So practically how it's dumped on your screen is something like this. Mm. So practically this is how your data would be dumped on the screen, and so on so. So these are bags which are separated by these braces or brackets, what we call. So if you look into the screen now, I have the data also ready for you. So if you can see, the data is done something like this, right? So this is your daily data, or the data on which I am looking at. That is my raw data on which I am working on. So if you can see, it's almost in a similar fashion what I was showing you, but some extra records also which I have ignored. Now I say group daily on stock. So what will happen up is this daily would be grouped on stock, and what will happen is, so GRPD, and this group will have few more things. One is your group. There's a new variable which will be there called group, and that will be a key to the group, and that group will have your stocks CII, ICICI, and INFI. So there are only 3 keys based on this data set which you are looking at right now. Considering this data set, we have these 3 keys, and each key will have the corresponding data, and it will be something like this. So this will have your this thing, this will have your this thing, and this will be the key for both the things, and this will also have your this thing, and your infi would have this. Everyone agrees, right? This is your data would be grouped. So when I say dump grouped, it would look something like this. A bag starting, and a bag will have first thing is a group ID. What is your CII, comma, all the tuples inside that, or all the tuples which are matching this grouping condition, that is who has the stock called CII. So here there is only one stock CII, so that will be inside your bag, and the bag will have tuple. So that will be something like this. Oops. something like this. CII, the curly braces for inner bracket and another bracket, and the top bracket closing. And for in ICICI it will be little different. It would be something like this. Other than this, there would be something called this, no, and so here we have two things, and this will not be closed over here. So this is how your CII data would look like. Two bags inside your, so two tuples inside your bag, and the key is not CII, sorry, ICICI. Make sense? Pradeep, make sense?
Yes, thank you.
Okay, so let's go back over there to the, so if I say over here now only over here, if we look over here, we can see the CII and the corresponding dailies or corresponding records which are having this stock CII, those are inside your bag. So let's go back to the PPT. And so now what I can do is, let's say what I have to do is for each group generate group comma count daily. So this will, what it will, can anyone guess what it will produce? For each group, the group is group of daily on stock. For each group generate group comma count daily. Can anyone guess what it will produce?
Number of entries by stock.
Yes, perfectly fine.
So basically it's CII 3, ICICI 4.
Yes,
like that.
yes. And why I have used daily over here? Count daily.
Because that's the table that has all the data, right?
That's the table that has all the data, but the bag which is created inside your group is named by the derived data set which was grouped. So here this bag is named as daily because this was derived from daily, because group is equals to group daily on stock. So this bag is always be the name of your derived variable from this group has been created. And the data inside that would be referring the data type inside the daily only. And but the key of the group is by the name of group only. And the data type of that might be different or based on the grouping criteria. So here I have grouped on stock, and you would see that stock data was carried only. And that's the reason I said count daily, because I am counting the tuples which are inside my group, and I'm saying count daily. It might be confusing, but try to understand all this thing. And if you are not able to understand it, I'll try to explain it again and again. So if I say, so we have just segregated 10 records out of our daily, and let's say group is equals to. So instead of daily, now I'm getting it from limited, that is only 10 records. By say I do it again on stock. Now say dump grouped, or say let's use to, okay, so that's a dumb group. So let it run in the backend for a minute and it will produce you the output, and then we can see some other things on that. So this is how I'll be referring the different fields inside the complex data types. Okay, so by the time it's running, let's look into a few other examples which I have for you. So here you've just seen this beginning, middle, end. We have just seen it, how to get them. Okay. Let's look into another complex data type and let's try to load it. Try to understand this complex data type, and if you are able to understand this complex data type, I think you would be able to understand all the complex data types also by the time the output is coming from that query. So before showing you this, let me show you the data and then we'll look into this data type what has been created over here. And before that, let me correct it. Oops. Okay, so let me show you this data. Give me a minute. I'm just opening it on my VM on the Hue UI. And let me share this thing with you. So this is the data. I'll just copy it and try to paste it on some text editor, and that will give you a good look of this data. So here, if you can see, we have few things. One is the name of the player. So this is the baseball data. One is the name of the player. Second is the name of the team with which player plays. Third is the positions where player plays. So these are inside a bag, and a bag has tuples which are nothing but the positions where player plays. Try to look at this data. I'll try to explain it again and again, but if you are able to understand it, you will be able to understand any complex data types in PIG. And after that, I have a map. If you remember, a map was started by a square bracket. The bags are started by curly brackets, and the normal brackets, or these are your tuples. And the bag contains pair of tuples, and square brackets are holding key and value pairs, and key and value pairs are segregated by hash. So you can see this is a key and the value. So this has different statistics about the player. How many games he played? He gave, so this George has played total 1954 games, hit by pitch 65, on base percentage 0.379, grand slam 7, home runs 243, and so on. So these are his different betting statistics which are inside the map. And similarly for other players.
I have a quick question. Can you on line 1, right above line 1, can you also put can you please put the actual code that you executed to get this output?
This is the data set. This is the data set which will be loading and will be playing with this.
Well, but I thought you already defined it.
Okay, so this is the data. So your data would be coming into a system. If you are loading this data in the PIG in the particular format, this your data should be looking like. Otherwise, you can play with the data and produce data something like this. So my data would have been in a single file without any braces or something. I would have grouped it and done different operations, then produce it.
Yeah, but can you? So right above line 1, can you put the DDL that you had on the other screen?
So that is
you had that.
No, that is a DDL which I'll be using to load this data.
I know. That's why I'm saying
Okay.
just put it above this so I can
Okay.
connect both together.
Okay. Well, I'll be coming to that part. Okay, sure.
Okay, never mind. That's okay. We're going to. I just think it'll be easier for us to understand that.
Okay. So this is the DDL
Yeah.
which we'll be
Thank
using
you.
up. So okay. So before going to the DDL, this is the data which has the name, the position where the player plays, and the bag of his positions, and we have the map of his scores or his different statistics, and the maps are represented by square brackets, and your key and value pairs are differentiated by these columns. So what I'm saying is load this file as name is the first variable name which I'm giving to it, and all of these things you can see are separated by tab. So first thing I have given it as a name of type char array. Second thing is the team for each place. Again, that is a char array. The third thing is the position where is placed, and that position is a bag. So we have to say is position colon bag, and bag has tuples of type char array. And then we have a bet, that is betting averages of which has maps, and we have loaded this data in the b-ball variable.
Okay, and so now you're saying that the map, where you're putting all, you're saying that the map is games hit by pitch. So that's the key and the value pairs. So the games
Yes.
is the key.
Yes.
And this map is now being served as the input. So this has already been calculated somehow.
Yes. So this is the data of some baseball team, and this is what is this has already been calculated somehow, and this is the data for different baseball players.
Okay, thank you.
So this is the part of the data which I've copied over here, and let's look at let's try to load this data. Oops. So here you can see the top 10 had a single group CLI, and all the variables inside that are this thing. So this is how somehow that data would have been created. We would have data for the different players. We would have calculated our averages on those kind of things, and then we have dumped that data. Now we are trying to load that data, and we have defined different names to this data, and this data is loaded for us. And now what I'm doing is I'm just making one operation on this data. What I'm saying is average, and I'm to find out betting average of different players. So what I'm saying is for each b-ball, that is the data which I've loaded, generate bet is my map name, if you can see. So bet colon, what is the key which I want to produce? Betting average. So the value of betting average will be produced on the screen for each average, or basically not produced on the screen, but assigned to this AVG variable. So the average variable will contain the betting average of all the players. So if I say illustrate AVG, so that will contain the betting average for all the players, but here it will just illustrate for only one player over here. So it has taken the player Stephen Dew, and if you can see his betting average is 0.27 and 0.27. Similarly, for all the players, the betting average would be given to average. Or if I say generate name, comma, that will make more sense. So this player did not have any betting average inside his score. So the betting the average is not been assigned to this player. So here I have defined the name as batting average. The spelling is a little incorrect. Sorry for that. So now see, the name is given as batting average to the by the pick, and the batting average for this player was 223, and the name was this. So let's say I want to find out the average batting average of all the picks. So what I'll now I have to do is what was average is equals to for each average, and I have to just say the average. I'm not sure the average function, what is the average function, AVG or average or capital or long, and the average and the batting average. So that will give the average of all the players to me. So this is how I'll be looking into the data, or I'm just telling you how to look into the data, how to read the data, how the bag and tuples look like, how you read the key and value pair from the maps. We'll show you some other examples which are there. So let's say so this is a filter example which I've already shown you. Filter divs not matches symbol this. So those will produce what are not matching CM starting with CM. You could have used starting with CM is equals to or also. Instead of matches we can give equals to also. Then we have just looked into the how to do a group by. So here I've just shown you the count of daily and average is AVG. Okay. So for each group generate group comma average daily comma dividend. So what I'm doing is I'm finding out the average dividend yield by each stock. So I've loaded the I basically grouped the daily based on two symbols over here, the stock as well as the exchange as well as the stock. And now I'm finding out the average dividend yield by each stock. So what I'm doing for each group, generate group, that is the exchange comma stock and the average of dividends. So guys, wherever you are not able to understand, please let me know. Silence really scares me. The dividends is not there. I think we have loaded that. So let's say open, I think would be there. Open is there. Again, it will take 2-3 minutes. So by the time, are you able to get it? I am trying to explain you different examples which are written, or I'm trying to write them. But are you able to get? Are you getting it? The difference between a tuple, bag, map. If you are able to understand tuple, bag, map, I think everything is clear in the pig. Nothing else is there in the pig. It's all about reading the data and processing it with the different operators available in the pig. Jignesh says kind of okay. If you are getting it kind of also, that's good enough. So see here the group is your stock as well as the exchange and the average open price of those stocks. So how quickly on a big now if I have terabytes or petabytes of the data, I have to just find out the average stock open price. The single line of code will do all the processing on your terabytes of data and will produce the results on the fly. And the pig flies. Okay, Pradeep says he is able to get the pig and the bag and the tuple. Vikram, isn't a group a keyword? how can we use it as an identifier? Okay. So what was that? Average. So this is group, and here is also the group, and both are automatically detected by your pig based on where you are using it. So if you are using it over here, it assumes that it is an operator, and if you are using it somehow as a variable, it will try to find out. I think this is a good point which Vikram you have raised. But this is how pig will automatically find out intelligently for you that the operator you are using it as an operator or as a variable. So this is your variable name also, and this is your operator also. For everyone, I'm just showing you on the screen also what Vikram has asked. And both of them are same, but based on where you are using it, it will try to produce output. And now if I say test is equals to for each average group dump test, it will just now it will find out what was that group that was not an operator but that was a variable, and will just produce the keys or the group IDs or this stop comma symbol and the output. So this is automatically detected at the back end by this language whether you're using that as an identifier or as an operator. Based on the position we are using it. So it will again take a minute or so to come up. So I hope everyone got what Pradeep was asking, what Vikram was asking. I think that was a good question which he has raised, or good point which he has raised, but everyone was able to get what he was asking.
Yeah, I have a quick question.
Yeah.
Maybe I missed earlier. So compared to Hive, where we first have to kind of define Hive interface for say before we execute the SQL-like command, right? And then it goes and do a MapReduce on its own. But that mapping of a Hive kind of tells which data files or objects we are looking at. So in pig here, where do we, when you have hundreds of different files, where do we specify where it's looking at for the execution?
So for all of these operations, if you look, the first command in my operation or in my pipeline is load. So there I say which data I want to load, and that load is pointing to some file in my SDFS, or basically some directory in my SDFS, or some file in my SDFS, and that load will load your data when you are, so this data, real data processing happens. So if you can see over here, whenever I say I define some variables,
But that load is actually pulling the full data set into some processing, or it's just pointing into
it is pointing. Yeah, that I was just coming to it. So if I say baseball equals to load this thing, and I say enter, it is loaded. And if I say test is equals to for each B ball generate name comma team, done. Practically nothing is happening at the back end. These are just the variables which are assigned. But when I really say dump or store test into at some place, say at some place, at that time the real processing happens. So if I say dump test on the screen, that time you will see that there's some processing which happens. So this processing happens when you do a dump or store. And when I define the variables, these are variables which are really initialized at the backend for you. Nothing else has happened. That there's a compilation of a program happens. The real loading of the data and all those things happen when you really store or dump the data. And we are pointing, as you can see now, I've just loaded some data set. So we are working on the data set which I have loaded in the load command. So any of a pig program, the first command would be load. All of a pig program would be starting with load only, and that load is nothing but loading the data from somewhere from a file system. So see, the real processing happened later on. And such a big amount of data was processed, not exactly processed, we did not do any processing practically. We are just filtering the file, or we are just getting two columns from the file. So, and those are produced over there.
Okay, got it. So you just have a metadata kind of setup with all the statements, and then when you actually store or execute it runs.
Yes, if you are a little bit familiar with Java, it's basically compile your program. It does the compilation of the program and practically run after when you say or when you trigger the command called store or dump. So it has done it has created the logic kind of thing for you, or I would say it has created the algorithm for you. So, yeah, jars, or yeah, you can not exactly jars, because jars are practically created when you say that's the reason I changed my example also. Rather than compilation, I was coming to the logic part. So it has a logic, and the logic is basically compiled and combined into jar, and that jar is submitted only when we call store. So if you see over it creates a jar also and submit it. For this program, it user track it at this URL, and it produces those things also. The jar created and all those things comes in somewhere in the logs. If you see the detail log, those will be there, and at the end it will also show you the records process, total bytes returned. The jar name might not be coming, but the jars are also created at the backend. The MapReduce jar, which is basically triggered for triggering your program. And here you can track the program. So here you can track the program. I am not sure did I show you the screen or not. Did I show you the screen? The job browser screen. So here you can see there was no reducer over here, and I hope everyone understand why there was no reducer over here, because we have just selected two columns. We did not did any processing on the data, and the mappers and reducers. We can look into the mappers ran. We can look into which node really the mapper ran. The logs which are generated from that mapper. This is the log which is generated from that mapper. It tried to save that output first at this location, a temporary location. This was a temporary location where a mapper produced an output, and then that was moved on to your LGFS world. So all this job history is available to you. You can look into this if you are facing some issues in the program, you are getting some errors. The first thing is go over these logs, try to figure out what is the problem. You can look all the logs. 198. All the jobs which are triggered. Let's look into some error jobs. Failed job. So it had some 7 mappers, all failed. So it tried to redo. It retried also, as I was saying you, and it was generating those errors. So this is how you will be debugging your programs really. You will be looking into the errors. You will be looking into the deeper logs. So here there's some issue while the mismatch in the key of the map. Expected is text, but received is your long writable. And so this is how you'll be really debugging your programs, looking into the different logs if you are really writing your scripts kind of thing. And now I can even look at which data node that mapper was first attempted at. And so these are the data nodes where those mapper were attempted at, the logs from different data nodes. So you can even find out there were some issues with particular data in a particular data node kind of thing, and then your job, that piece of the job has been submitted to some other data node kind of things. Pawan said no. I'm not sure what for you said, Pawan, no. Okay, might be for this UI. Okay. So if I've not shown you this UI that runs on 8888, not on 888, sorry, 8088. 8088 is the port on which this you would be able to see your job browser. 8088 127.0.0.1:8088. And for that thing, just make this entry in your host file, so that each time you don't have to change it. So it will try to use the URL sandbox.hottenworks.com. So if you make this sandbox.hottenworks.com as an entry in your host file, you don't have to change the URL over here again and again to 127.0.0.1. So you can just make this entry in your host file, so that you can browse it. Otherwise, it will give you does not found each time. So you have to physically change the URL over here again and again to 127.0.0.1. So if right now you are trying on your PC, that you'll be seeing an error, not found. So change the URL to 127.0.0.1. Otherwise, make an entry in your host file. Okay. So Pawan says how to make an entry in the host file. So Pawan, go to Windows, go to C: Windows System32 conf etc, and inside there is a file called host host. Right click it, open it, and once you open it, I'll show you how the file would look like. The file might be a different location based on your Windows version or based on what you're using. But let me show you quickly. So 1 minute. Windows, I am on Windows 7. File might differ a little bit. Windows System32 config, not config, System32 drivers etc and host, and right click it, edit with Notepad++, and see 127.0.0.1 to sandbox.hottenworks.com. So this is how you'll be making an entry into your host file, so that you don't have to change your URL again and again. Pawan, I quickly remove that because there was some private IPs of mine. I'll ping you it on the chat window. So this is what an entry you have to make. Okay, so where was I? Okay, so we were looking into different examples other than this. So let's see what else is there. So we have just looked into the group count daily. And then filter we have just looked. We have looked into the group. Let's look into the order and other examples. So order, I hope everyone understand order by. So let's do, rather than going to the PPT, I'll show you over here only. So what I'm doing is over here is order daily by close, descending and open. So my record would be ordered based on the closing price, the top closing price, and the open is the second criteria of sorting if the closing price is same for two different entries in my data set. So I'll go back over here on the same UI because here my data is already defined. So this is ordered, and if I say dump them on the screen only, dump. So my data would be sorted based on the closing price of the stocks, and this is a little bit big data set. It might take some time, and by the time it's dumping on the screen, let's switch back to the PPT. So order daily by date and symbol. So I hope you understand here I'm ordering the daily by date and then by symbol. So it's the first level of ordering on the date and then on the symbol. So this is how you could be ordering on the two keys or a single key over here by date. So there what I'm doing is distinct the daily. I hope you understand what I'm doing over here. I'm trying to find only the distinct records. So this is again a useful operator you might be using. It removes or duplicates from your record. Okay, and the most useful thing, join. So here what we are doing is, why my screen sharing is paused. Here what I'm doing is I have a data set called daily. I have a data set called divs. Both of them have something called symbol. I'm joining them both. Join daily by symbol, divs by symbol. So my both the data sets will be joined based on symbol as I've shown you previously. Here I am joining them on two parameters, not only symbol but on the date also. So I'm joining them on the symbol and the date. So only the mapping criteria, that is the symbol and the date of first data set matches the symbol and the date of the second data set, then only those data sets would be joined over here in this example. So rather than joining on the one criteria or the one joining column, I can join them on n joining columns. And here what I'm doing is left outer join, and similarly you can use right outer join also. I hope everyone understand what is left outer join, and I don't know to define that. If anyone want me to explain what is left outer join, please let me know. Otherwise, I think we have discussed this thing in high part also. So left outer join, we can define it something like this. Similarly, right outer joins also. And if I want to join three data sets, A by X, B by U, C by E, and the three data sets would be joined. So this is how I'll be joining my data. Any questions on the joining part? Okay. Okay. So yeah, very much similar, only the little syntax changes, that's nothing else. I'm limiting my data. So this you will be using a lot for your testing kind of purpose or those kind of thing. What I'm saying is limit divs by 10. So only 10 rows would be loaded or used from your divs variable. And that you can use for your debugging kind of thing and all those kind of thing. So limit is similar to what we have used limit in the Hive or SQL queries, limiting the data for our testing purpose, looking into the data and those kind of things. Okay, the parallel clause can be attached to any operator in the pig Latin. It controls your reducer. So here what I'm saying is I am defining number of reducers which would be created while running your job. So it's similar to the operator which we gave in MapReduce word. If you remember, we executed one program where we use partitioning and we define explicitly number of reducers equals to 3. And I hope now everyone understand we can't define number of mappers, but we can only define number of reducers. And I hope everyone understand why we can't define number of mappers, because they depend on the splits. But the number of reducer I can define up. So that could be defined with the parallelism and pig. So if I say over here parallel 10, that will ensure 10 reducers would be created for your program to run or for this operation to run. And I hope now you understand this example where your parallel would make sense. The operators which would be running in your reducer phase would be making sense in the parallel operation if I define parallel for them. The operators which would be running in your mapper phase would not make sense if I say parallel to them. So here if I say group daily by symbol parallel 10, so that would be using 10 reducers to do a grouping of your daily data by symbol. So here I can define the number of reducers which will be initiated for this thing. So let's try to use this and see the data. So see, the previous example is also ran by now. Oops, not this one, this one. So what we ran previously, dump by close. So yeah, ordered it. So it's ordered on the closing price probably. This is the, which is the closing price over here. I think probably this one. So this is increasing, and the top one might have your biggest. So what I was showing you is parallel 10. Okay. Base bar group is equals to group by team parallel 10 P-A-R-A-L-L, parallel, is this the correct spelling? Baseball looks correct. Oops, group spelling. So let's track this job. So here is the UI where I'm tracking this job. So you can look at the different phases of the program. Tracking URL is still unassigned. The job is probably till now not started. Now seem to be started. So it's application master, which is being tracked right now. If we can look at the application master URL also. Now what I'm doing, I think everyone is getting it. Application master, everyone can recall what is application master, what was your containers, what was your node managers and all those things. So these all are visible over here on the UI now. The job is running at the back end. So this is your job ID. If you can see, the total reducers are 10. Reducers completed 1, mappers total 1, mappers completed 1. So there was one mapper which loaded your data because there was small data. but reducers now are 10 reducers created, one of them is completed. So over here, if you can see, the mappers are, none of the mappers is running now. All the mappers are completed, successfully 1, reducers, new 4, running 3, successful 3. So total 10. We can look at the successful reducers also. So we can also look at the current progress of our program. We can look at the successful reducers, their logs, and so on. And over there, it's still running. The program is still running. Let me switch you back to the Dinesh. What you said, please share. What to share?
That's okay, but that the screen was not showing up, so I didn't know whether you were sharing.
Oh,
Maybe it's delayed.
okay.
It's okay now.
You can see it now.
Yeah, it's okay.
Okay. So see, it's still running, and the number of reducers was created 10, and the data is dumped on you on the screen. I not stored it into the file, otherwise you can understand how much files would have been created. Okay, we forgot to take a break. Let's complete the pig, then take a break. I think I forgot to take the break today. So there's nothing much more left over here. We can, let me see how much is left. There are a few more I think left. No, 1 minute. Okay, only the flattened part and UDF part. Okay, let's cover that after the break. Let's take a break. We forgot to take the break. Which let's take at 15 minute or 10 minutes break. It's 10:15 my 10:51 in my watch IST. Let's meet around 11:05 IST.
Hey, Meeraj, what are we going to discuss after this?
Yeah. So after PEG, if you want to do some program, I can share the program, or if you want to start a streaming part, then we'll start the Hadoop streaming.
Okay, so we'll have to wait for everybody to weigh in, right? Okay. Because everybody should take a vote, right? Whether they want to do practice or whether we want to go on.
Yeah. So
Okay.
it's on a wish. So if anyone want to practice, or if someone want to practice, then we can practice somewhat on the PEG. Otherwise, we'll start the streaming part, and after that, there's nothing much technical side. Then we'll be just looking into the scoop, which is nothing more than half an hour session, and the Uzi is again not more than half an hour. So these are the two topics which will be remaining as a part of technical thing. Otherwise, we'll look into how the data looked into the Tableau part. So I think 2 classes would require to cover these 2 things, and then I'll be giving a project which then we'll be discussing that project, whether everyone is able to do at least some part of the project. Hi everyone, I'm back. Do let me know if you're back.
Hey sir, this is Zubair. I just wanted to confirm that, sir, did you get a chance to send me the classes for last week?
Jubair, I've already shared with you. Check your
Gmail?
yeah, Gmail. I think I've already sent a request, and please drop an email to admin team so that they can share, because I forgot. But
I already emailed the admin team also, sir, but I didn't get any reply from their side. I
just,
have
I think
emailed
that is already
to...
shared. That would have already shared to you. Just check your Gmail. You would have got an email from design parcel at the Gmail. The video has been shared, something like this. Just check out your Gmail account.
Yeah, just check, sir. I don't have that here, but I've emailed to admin at Design Pathshala also like 2 days back regarding those.
Okay, I'll cross check.
Yes, sir, please. Thank you. And also, sir, if I want to contact you, so I can email or I can text you on Skype, or do I have to send you an email or call you on some number, sir?
You can directly drop an email on my email ID. I think you have my email ID, right?
Yes, sir. Let me double check your email.
It's miraj@designparcel.com.
One second. Could you spell it for me, sir? VIRAG?
MIRAJ.
MIRAJ?
@designparcel.com.
Alright, sir. Thank you.
You can directly drop me an email.
Alright.
Okay. So Pawan is back. Zubair is back. Vikram is back. Okay. So Vikram is also back. Pawan is back. Zubair is back. And Emily, Arvind Kejriwal. Oh, they would be coming in a minute or so. So I'll just share my screen. Okay, so my screen is already shared. So what I was saying was, before we got back, so parallel is a command used to parallelize your operation. And if you want to set the default parallel operations, you can just say set and default underscore parallel to 10. So that will ensure all your operations are done with 10 reducers. So this is a skip wide operation here I have done for a statement-wide operation, but here I did on the file-wide operation. So here I can define for the whole file also. Similar way, if I say set default parallel to 10 on the pig console, I can do it for that session of the pig. Okay, so this is how parallel helps you to define the number of reducers. That is, you are doing the task parallelly at the reducer side. Okay. So Jignesh, we were just looking into setting the parallelism for the whole file. So if you want to set the parallelism for the whole file or the whole operation which will be running inside my script, I can just say set default equals to default parallel 10. So this will ensure the number of reducers will be triggered for your whole operation when I'm running the file by the operation of pig minus f and the file name. Or if I am on the pig console, on the grunt console, I can say it's default underscore parallel to 10, and that will ensure all the operations which are triggered in that console in that session are triggered with a parallelism of 10. So flatten is your operator which is vice versa of your group by operator. So say my data is something like this, which is grouped based on your different things. If I say flatten, that will flatten up. That means for each of your group, it will create a new row. And kind of this. So here what I said is, if you look at over here, what I say is for each player generate name, that is the name of the player, and flatten position as position. So name and the position. So if there are two positions, there will be two rows, name and the position. So flatten is reverse of your group operation. And then the last thing, UDFs, you can create UDF if you want to create your own functions. If you are not satisfied with the functions which are available to you from the pig, you can create the UDF, and all you have to do is when you create your UDF, you will be creating a ZAR. I hope everyone understands now how to create a ZAR. You create a ZAR and register your ZAR with the file, the location of the ZAR and the piggybank.zar. Your local Unix path to your jar. So this is your local Unix path which will be defining in the file, and then you can directly use the different methods which you have created in the file or in your jar. So here I am giving the fully qualified class name and the input parameters of my function. So here I am calling function which is reversing my symbol, so this will produce you the reverse of symbol. And as I was showing you previously, piggybank is already available jar which have a lot of UDFs for us. And if you just look into Google, just Google piggybank, and that will give you all the functions which are there in the piggybank. And you can use them. Most of the functions which you might think of for string operations, mathematical operations are there in the piggybank, and you can directly use them rather than creating your own UDF. Otherwise, you can create your own UDF. All you have to do is just implement some interfaces and create a jar, and you can use that jar as your UDF. If you want me to show the UDF program, do let me know. I'll open some Java program and show it to you right away. How to create a UDF. You can create UDF in other languages also. So this is a UDF in Python. Here what I'm doing is I am defining this Python script as my UDF, and the name is given as bball UDF. And how I'm calling this is bball UDF dot function. That is a function in this script, defined in this script. So this script has this function. So when I'm calling this, all I have to do, I have to just give the input parameters to this function, whatsoever the function is defined, the production.py, and that will, and output will be given to your program. So this is also this is how you can create UDFs in other languages other than Java. So in this Python, there is nothing but the Python file, and that Python file has one function by the name of production. And when the operation comes to this line, So for each record in your not null operator, the baseball UDF.production would be called up, and that will do something. I am not sure. So this Python I don't have over here. So, but you can create any function in your scripting language and call it this way. Making sense? So, but before that, you have to register your file, and this is how I am registering my file over here. Register python.py using JJthon is a library to run your Python. And I've given the name to this thing so that I can refer it by this name. So we have just seen the UDF, how we created the UDF in Java file, and okay, so this is nothing but the summary of what we have done till now, or what we have discussed over here. So it's a good interface over MapReduce, but the lower integrities might be difficult for some of the things which you can think of in your real-time world. But it with the help of Pig, you can create big data chains, big work pipelines, and it's a good and sweet spot between a MapReduce and a kind of SQL language. So, any questions over here? Anything which anyone want to ask? So here, see, I am loading this piggybank.jar and using this reverse symbol. So this will do nothing but reverse your symbols. So this is a function which reverses the symbol. And if I say as such, what was the file name? Or what? Or rather than say, but this file has. Okay, this file don't have anything. So pig -f. But I am not dumping it over here, so let's copy it. I am not dumping it. So let's first register this. So I have registered it, and then I can call this, and then I say dump. Error, what is the error? Okay, so divs is not defined. Daily is defined in this session. Okay, so stock is there in the daily, and dump the backward. Okay, Pradeep. Anyone? So this is running. I've defined the function. I've used the function, and same way you can create your own functions and can use them UDFs. Any questions on this big part by the time this program is running? Okay. So then we have few others. I'm just unmuting everyone so that everyone can participate in the discussion by the time this program is running up. So what I was saying is, so after this pig, we have few more things to discuss. One is your Hadoop streaming, where you can write your mapper and reducer in any other streaming language, whichever can read your data on the input/output of on your IOs. And so there you don't have to write your Java code, but you can even create your MapReduce programs and can run them. So here the pig and so all the symbols are reversed. CVA and all those things. So that is Hadoop streaming. I normally take that try to Hive and pig, but In this batch, I've taken it. I've not taken Hadoop streaming prior, Hadoop prior, Pig and Hive. So Pig and Hive basically create a MapReduce program at the backend for you. But in Hadoop streaming, same way as we did in MapReduce Word, we create a MapReducer program. But in any other scripting language, if you are not familiar with the Java word. Then we have Scoop and Uzi. And then we'll be looking into how to load this or get this data into any of the reporting tools and how to visualize this data. So the Scoop, Uzi and reporting tool would not take more than half an hour each, or probably one session. And then we have a Hadoop streaming part. So before moving to all these things, so would you want to do a problem statement on the pig part, or you people want to move away to the new topic? Do you want to try it out? Something on the pig, understand the complex data types and all those things. Want to try out something? Yes, no, anything? I would move on, but will there be enough time? Enough time for Pradeep?
Yeah, because I think everybody will want to get off by 1:30. Do you think if we start off the exercise, will everybody be able to get it done by 1:30?
Yeah, people not might be able to, but then you can try it at the back end for yourself. And but if you are facing some issues, I'll try to help you. And we have around 40 minutes.
The thing is, when we are doing the exercise, we need your help because everybody gets stuck up in some place or the other.
Yeah.
And then it could then mean a long time for the exercise to get done. So I'm just thinking, is it better to just start off with the exercise tomorrow and we just finish all the theory today, but then tomorrow we do the exercise?
As whatsoever way you wish. It's all up to you people to decide up. That's the reason I've unmuted everyone. So
okay, I'm just making that proposition that we do the class today, but then we start off with the exercise tomorrow. That would be my choice.
Okay, what about others? Zubair, Vikram, Pavan, Emily, Jignesh, and I think Arvind was already speaking. Okay, Jignesh also said let's. Okay, sure. So let me open the Hadoop streaming part. Or shall I show you the Scoop part? We have 40 minutes. Hadoop streaming also will not be able to cover up. Scoop we can cover up in 40 minutes. So, okay, let's look into the Scoop, then Hadoop streaming we can look on later on. Scoop I don't have much PPTs also, so I'll show you the things, how to get in the data and those kind of things. Just wait for 5 minutes there and let me open up the things. Okay, so I'm just sharing my screen in a minute. Okay. So then let me mute everyone. So I think I've already shared the pig sample, sorry, exercise with everyone, probably I think today or yesterday. So I hope you would have received that, and you can just try it out something or try to read that out, and we can discuss definitely that thing in tomorrow's class. And let's look into the scoop part, because streaming we might not be able to cover up right away. And the scoop you don't have to do much exercise also. So streaming you might also want to try. So we'll talk about how to do streaming tomorrow. Okay. So scoop is basically used to get in the data into a system and export the data out of a system. So when you have the data in your, just a sec. So now, as we were till now looking into the data which is there in our system, but how to get in the data. So there are different things which you'll be using in to get in the data. Mostly when you are getting the data from your, RDBMS word, you will be using a scoop. So scoop helps you to get in the data from your RDBMS word into your big data clusters. So probably what would be happening up at the back end is these scoop jobs will be running daily or hourly or kind of those things on your databases, and they would be importing in the data into your Hadoop cluster that will be further on using to process that data. And so practically what will be happening is not only the scoop part, you would be getting the data with other sources also, and then you will be marrying the data from different sources with the traditional, with your relational data, and you will be coming up with different insights in the data. So Scoop helps you to connect to your traditional RDBMS word and get in the data into the Hadoop word. So I don't have any dedicated PPTs for Scoop thing, but let me try to show you. I'll share this whole file with you. What all the commands which I'm discussing about Scoop. It's pretty easy, pretty simple. Nothing great, a single liner kind of commands which helps you to get in the data or export the data. So, and once the data is processed, you can also export the data from the Scoop to your RDBMS world. Okay, so Jignesh, I hope you can recall whatsoever project you had worked on, but the data in your productionized systems are archived after 2 years or 1 year of time. The data from those systems are either deleted or archived after a time frame of 3 years, 2 years kind of time, because if we keep the data, historical data into our systems, our current production queries run very slow. Then such a big amount of data we can't handle in our RDBMS world. If the table size grows, 50 GB, 100 GB, 200 GB kind of thing, I have to create indexes on the table, and the indexes also need to be recreated kind of things. That performance on the table reduces drastically. So I keep on deleting my data from the production systems. And even if the data is not too big, but that data is required, because say I'll give you one example. Say I have my website. Say I am working on Amazon. Whenever I look for any product on the Amazon, there's a request which comes to my servers, and the server respond to the request that this is a project, this is a product name based on the user search criteria and number of things, whatsoever is displayed on the UI. This is the product name, the price of the product, and so on. So this request is returned from your servers. So this all requests would be logged into your server logs practically for any website. Whatever request came to my system, what has been returned to the users, and all those things. And when user really clicks on any product and clicks on add to cart, so that is a kind of created order. He's trying to create his order. He's trying to add the product to his cart. That thing would be given to your RDBMS world or your databases. But all the requests which he's looked into, or all the products which is looked into, would not be practically going into your database, because no one is trying to store all an activity of a user. That would be just going to your web server logs. And now when he really pays for the product which is added to the cart, he has really confirmed the order. So there are three phases of any e-retailer website kind of thing. Get quote, where my server is returning the quote for a commodity, create order, and confirmed order. Now I have to do analytics on my system, what kind of orders, or basically I have to increase the conversion on my system. I want to look at the different conversion analytics on my system. So in this case, I'll be looking at the three data. One is the data generated from web servers, where I have all the quote related requests, which all products have been quoted from different geographies across the world. Then I have created order request in my database, and I have confirmed order request in my database. So now I have records from two different systems. I can't merge them, marry them in my Oracle world. What I'll be doing is I'll be exporting those records from Oracle world, the create order and confirm order records, into a Hadoop world. I'll be importing the data of web server logs from my web server, producing or extracting out the data which is related to request logs, merging both the data sets, and then based on that married data of quote, confirm, and create order data, I'll be doing analytics how to increase conversion. At that data, I'll be looking at different things, the demographics of the user, which part of the users are logging into my website, so that I can display the correct product to the corresponding IP address domains. I can give corresponding offers to the different IP address domains. I can do a number of things to increase the conversion. So this is just one example which I am giving you, why you would be really importing the data from your RDBMS only to the Hadoop world. That is the first step which you will be doing if you are moving to the big data platform. Make some sense? Yes, so once you get in the data, now if I get in the data, I have done some analytics, I have done some algorithms on the data, I have processed the unstructured data, there's the logs data, I have married that data with the structured data, it is my create order and the confirmed order data. Now once I've married that to the data together, I have found out some analytics. So say I am doing the analytics, a kind of thing which is I'm just mapping the IP address of the and the user demographics with the created and confirmed order that was there in my get quote request. So I married those things together. Now I want that data back into my RDBMS. So that case also Scoop will be helping you. Once you have done those kind of analytics, you are exporting that data again to your RDBMS world for n number of different reasons. Okay, so Scoop helps you in both the cases, importing the data and exporting the data. And for unstructured data or loss kind of thing, you might be using Flume. Flume is also very much similar. Although we will not be covering the Flume part, but if you look into this, that's also very much similar. You can trigger the single command kind of thing. You have to do some configurations, and you can get on the data, unstructured data. So this is in your sandboxes. There is a MySQL server which is also running, and to log into the MySQL server, just say MySQL and user is root, and the password is nothing, no password by default. You can create your own password and other users also, but the default user root which is already existing in your sandboxes, the sandbox which I've shared with you. So what I have to do is how to connect to your SQL world from the Scoop. All you have to say is scoop and minus minus connect and the connection string. So here I am using user as Jan Pathshala and the password is Jan Pathshala. So I think that is the user and the password in my VM, but you can use directly the root thing. So here I am saying is scoop list databases and connect to your okay. So here I am connecting to SQL server, that is my Microsoft MySQL. That is also running as a server on my PC, but that's not running on your servers. On yours, it's running as MySQL server. So all of the MySQL servers, SQL servers. Just a minute, guys. Let me open the MySQL file. Okay. So I think this would also help you to connect to MySQL also. So there's a MySQL which is running, and JDBC SQL Server 127 that's running on the IP address 127.0.0.1.1, but the default port is 3306, and the user is root, and the password there is no password. And if I say list database, that will list the database in my MySQL server. So let me open the MySQL first, and then let's use a scoop and let's try to use these commands. So let me open two putty sessions. So I hope you can see my current session. So I'm just quitting the pic over here, and so MySQL. I'm logging into MySQL server -u. So this is my MySQL. If I say show bases, these are the databases in my MySQL server. DP Hive. Now you can see Hive. This is the database which is created by Hive, and this MySQL server is used by the Hive at the backend to store some of your metadata related things. Also, your Uzi stores in some databases. Derby database, its jobs. So these technologies at the backend, it might be using your RDBMS word to store some of their metadata related things. So here I have new database which I have created for myself, that is DP Design Pathshala. And so let's look at the command on the scoop word, how to look at the databases, and then we'll slowly look into other commands of the scoop. So I'm not sure if I have the username database or so Design Pathshala. So I'll use the root one. Oh, there's some password also. One minute. I'm not sure what is the password. Just a minute. We'll use the root user right now. I don't remember what is the password of this Design Pathshala user. So what I'm saying is scoop. Scoop is the command to interact with scoop. List databases will do nothing, but will list all the databases inside your server which I'm connecting to. So here I'm using the connection string JDBC SQL Server 127.0.0.1, and the username is root. Okay, so Pawan, Scoop is different from Hive. A Scoop will help you to import the data into your SDFS world. So when just wait for 5-10 more minutes, I'll show you the commands how to import the data. Right now, I am just running the command to interact with my MySQL world. I'm just interacting with and looking into the databases which are there in the MySQL world. Just wait for 10 more minutes. I'll show you how to import the data. Scoop will not do any processing on the data. Hive is used for data processing. Scoop is just to get in the data and get out the data from an SDFS thing. So the data which you have in SDFS is processed by Hive. So the data which is scooped in to your SDFS, you would be creating Hive table on the data files, and those data files you would be using for processing with the help of Hive or Pig. And that processed data again you might be exporting or scooping out from SDFS world to your MySQL world or RDMMS world. Well, this is MySQL string only. Just a minute, guys. Sorry for that. Make sense, Jignesh? Oh, sorry, Pawan. Does it make sense? So, I'm just changing this. I don't have the SQL server running. That's the reason I'm just changing it. Give me a minute. I'm just changing it to connect to MySQL world. So, and here I can just see give the database name. So let me change the first thing. And let me change it. So this is how you can give the username and the password, but I am just changing it to the MySQL syntax. So only the thing what changes this connection parameter. There is a SQL server which I have defined as the connection parameter over here to connect it to my Microsoft SQL. Here right now I'm connected to MySQL, so I have just used the MySQL connector, and the IP address is 127.0.0.1. And this is the database to which it's connecting to. I can say without this also, I can say the database also to which it to connect to. And even if I connect to a particular database, it will print you all the databases. So these are the databases which are there in the MySQL world. Let's try to use the scoop command to look in to connect to the MySQL world. So it's running. Give it a minute. running very slow. So basically right now it's trying to connect to the MySQL on this IP address and trying to get all the database list from there, and will print it us on the screen. Looks to be little slow. So I hope everyone understand what is the error which we were getting previously. I was trying to connect to the MySQL word, but the MySQL server was not running, and all my strings had the MySQL connection only. So I just changed to Microsoft SQL only, and I just changed to the MySQL connection string. I've given the MySQL connection string instead of the previously what we were giving was the SQL server, that is the Microsoft SQL connection string. But I think that was not running, and the design person was the user for that server only. But that server is not running, and I don't want to run that right now. So I've just connected to the MySQL server, which I was showing on this other, console on which I've connected to. And now I've connected to this with the help of a scoop, and I've just listed all the databases inside this MySQL server. And these are the 5 databases, and these all are also visible with the help of Scoop. So I've connected to the server. My connection is successful to the server. Let's try to run other commands on this MySQL server, and let's try to see what all Scoop can do for us. Same way I can say list tables, that will list the tables onto the database where I'm connecting to. So sorry, not this one, the other one, and is anyone pinging? Okay. So cat show tables. So see how I'm saying over here list tables, and the list tables connect to this IP address, and this is the database name and the username by which I'm connected to. The password is not there, otherwise I have to give minus password and the password also, or I can just say minus p and it will prompt me for the password. So this will again connect to a MySQL word on this database, and will show you the tables inside that database. So there's only 2 tables in that database. One is called dim country, and another one is called dim country _1. Use dp show tables, 2 countries over here. Now let's try to do an import of the data and other things. So if I say I want to import some table from my database, all I have to say is scoop import the connection parameters to the database, the table name, and the target directory where I want to import the data. Okay, so let's go back, and before that let me replace this thing everywhere with the MySQL word, and that would be useful for us to directly copy it and so that we can directly copy it to run it. Oops, sorry. So now I can directly copy these commands. Otherwise it takes me also a time to copy it and all those things. So minus table name, target directory where I want to import it, and that will import the data for me in the target directory. So let's try to run it. So I have some of them over here, but others I will copy it from there. So here what I'm doing is I'm saying import connection parameter, connect to this database. The password is not required because the root user don't have the password. The table name which I want to import and the target directory where I want to import. Okay, so my screen is shared. Can you see it now? No. What happened? What happened? What happened to this go-to meeting? Can you see it now? No. What happened? Everyone can hear me at least, right? What happened? I'm just trying to figure out what is the problem. I am really not able to understand why the screen is not here. Pradeep, are you able to see my screen? Pradeep said yes.
I can see your screen. I can only, it says waiting to view your screen, so I cannot see it.
Oh, okay. I'm just giving the presenter role to someone else and will try to get back the presenter role. I'm not sure what has happened. I'm just giving the presenter role to someone else and again get back to it to me. I'm not sure what has happened. So, okay. And I think still you people are not able to see my screen. Well, this button is still not green. Okay, now I think everyone can see my screen. So I don't know, somehow I think, I don't know what happened, but I just gave the presenter right to someone else and took back and that gave me the screen sharing. Somehow it got stuck. So, okay. So you can see it. So what I was saying is, so let's try to import some data into SD first word from some of the table. So what I'm doing is I'm connecting to scoop and I'm giving the scoop import command, the connection parameter where to connect to, what is your MySQL or RDBMS connection string, and the table which you want to import, and the target directory where you want to import this data. Okay, so let's now hope you understand why I would release the directory first, because the MapReduce program which will be created by the scoop word to import the data would want this directory not to be existing up. So let me create this directory first. So I'm just deleting this directory from there to run the scoop command. and then I will run the scoop command to get in the data to this directory from the RDMMS world. And the scoop is very fast to import the data or export the data. It works very fast, tremendously fast. On this single node VM on my PC, it might look pretty slow to you, but practically when you run it on cluster, it's very fast. Looks like my PC requires a real restart. I'm not sure when the last time it was restarted. Okay, so it says deleted. Oh, Uzi nobody. Okay. So let's try to import the data. So scoop import the table which I want to import and the target directory where I want to import. And by the time it's importing, it's creating a MapReduce job for us at the back end. Let's quickly look into the data in the table. So let me go back to the MySQL world and say select a star from this table. So this table has all these records for a country. There are different things. So small name, country name, ISO code, IMS code, and the unique key for that country. And let me switch back to the scoop. So see, it has created your job somewhere, and you can see it's trying to run the query, trying to find out the dim, max, and min IDs of the primary key of this table. And I'll just quickly tell you why that is required, why the scoop uses it. And here is the MapReduce program which has been created, can be tracked off this URL. This is the job ID. And for a scoop just write the Java code, and the Java code would be visible in the same directory where the scoop command has been triggered. Like pig and hive also create the code at the backend, but those were submitted by the job directly. But the Java file for the scoop which is created is also available where the scoop program has been triggered. Can anyone think of, by the time scoop is running, why it has fetched the max and min primary keys before importing the data? First, try to connect to the table and tries to validate all the things that the table is really existing. It tries to look at the schema of the table so that it has to find out which all columns need to be imported and all those things like that. And then it will import the data. But other than that, it tried to get the primary key also from the table, from the MySQL MySQL table definition. It figured out what is the primary key of the table, and it ran the query select min and max from this table. Can anyone think of what could have been the reason why it has tried to find out this max and mins of the table of the primary key before really running your job? Reducer would come later on, Pradeep. Before that, the mapper phase will run, and here the mapper is not reading the data from the input streams. Here the mapper is reading data from the MySQL world. So practically, Pradeep, you are going to the very right direction, but here the concept is really little different. Here I am reading the data from the MySQL world. So this will help me into calculating the number of splits, which is like next slide saying, and the number of splits are based on the data which will be given to the mapper. And the data over here is not really read from SDFS world because we are importing the data from somewhere else. and so it will trigger your. So I'm just opening the application. So if you can see, here are the 4 mappers which were triggered. So that will so based on the number of splits, and the number of splits are the data which need to be read from your Oracle word or MySQL word into LGFS. So these mapper will really read your data and will produce the output into your LGFS word. And there is no reducer required in this phase. I hope you understand why the no reducer is required. And to get in the how, so to get the calculation how many number of mappers are required to fetch the whole data, it tries to find out the min and max values, and based on the total number of values which need to be imported, it's try to find out how many number of mappers which are required to import the data. So does that make sense to everyone? Does everyone get it what I was trying to say? Over here we are not reading the data from LGFS, however we are practically importing the data to LGFS. And if you see over here, there is a dim country.java which is created by the Scoop for us. And if I say cat, practically you can see the code which has been created by Scoop just to import one table. When we write complex things, you can think of the complexity of the code. So let's look into other things. We are already running up with the time. So okay, we'll look into the other Scoop commands. I think next time there are a lot of others. There are a lot of others. So we have just seen into the import thing. There are a lot of other things. We'll look into them, but at least this gives you some idea what Scoop is doing. And there's a MySQL instance which is running on your sandboxes also. We'll look into the other Scoop commands and what other features are available in the Scoop for import and export the data, how we can get the incremental data daily. Practically, you will not be importing the whole table daily. So you will be configuring the Scoop jobs which will be running daily and getting only the incremental or updated data from your RDBMS word into a Hadoop word, and then you will be using that data for daily processing or daily batch jobs running into a Hadoop cluster. So we'll look into that, how to get in the daily updated data kind of things. And we'll do the hands-on on the pick in the tomorrow's class. So anything else before we wind up? Because there are other things also, but let's try to cover them because the time is already over. Otherwise, we'll again overshoot the time today. Sure, Pawan. You can call me directly. I'll send you my number. That is 96502. Pawan, I've sent you the number. I think I've sent it to everyone indeed. If you want to talk, you can just directly buzz me, but I have an India timing, so you can buzz me on the India timings. Pawan, you can but call me if you want to talk right now. I am awake. Anyone has anything else? Zubair, you can drop the email again to the admin team, CC me. I'll check why the recording is not shared with you. Sure, Jignesh, bye bye. Okay, Zubair, thank you. Thanks everyone. Thanks family. Thanks Pawan. Thanks Pradeep.